Okay, so we are nearly done filling in all of these tables. And I'll note that sort of each corner of this table has had a certain type of problem that we associate it with. So the lower left square was the candy to children type of problem. The lower right square was the partition problem. The upper right square was the big S Stirling number problem. Okay. And finally, we're at the upper left square, which I already sort of gave away in the first video, corresponds to the functions from m to n problem, which is definitely one that we have thought about a large number of times. So we in the very first video filled in, okay, the number of ways to send n distinguishable objects to n distinguishable boxes. That's the same as the number of functions from the set m to the set n, and that is n to the m. Okay, great. So let's now look at these two remaining ones. Okay. These each correspond to a particular restriction that we could put on functions. Okay. And if you had to pick two particular restrictions that you could put on functions and guess what they were going to be, you would be exactly right. Namely, this statement that at most one object goes in each box. That corresponds exactly to saying the function is one-to-one. And this statement that at least one object goes in each box corresponds to saying that the function is onto. Okay, so this is really asking how many one-to-one functions are there from m to n. This is really asking how many onto functions are there from m to n. Okay, quick refresher before I answer it. Which of those questions is easy and which of those questions is hard? I'll pause a minute and let you think about this. Okay, the easy one is one-to-one. So that is to say, this is the one that we did the first week of class. So how many ways are there to make a one-to-one function here? Well, it looks like this. Well, my first choice here is where does 1 go? Okay, and there are n options for that. And then choice 2 is where does 2 go? And so now, because I'm insisting that this function be one-to-one, I can't send 2 where 1 went, so there's now n minus 1 options. And this is going to continue until we get to my final choice, which will be choice m. Where does m go? And so now we have to think, okay, so that means there's m minus 1 things that we can't choose. So this is n minus m plus 1 options. Okay. Which is to say that the total number of one-to-one functions from the set m to the set n is going to be n times n minus 1 times dot 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 times n minus m plus 1. Okay. But here's where we might realize we have a name for this number. Namely, this number is the big P number, big P of nk. Sorry, big P of what? I'll give you a second to think about this. Namely, it is big P of mn. Okay. Wait, mn or nm? Big P of nm. Sorry, that took a second. Okay, this is big P of nm. So if you were thinking that hadn't shown up yet, well, there we go. There's that one. Okay, So that leaves us with one box and one question left. Okay, and that one box and that one question is how many onto functions are there from the set M to the set N. And the way we can look at that is actually to look at the box to the right of this box. And remember that this is the number of ways to put M distinguishable objects in N indistinguishable boxes. Okay. So one way to think about this is that I can start with an arrangement here, and then I can ask myself, okay, well, if I started with an arrangement here where the boxes were unlabeled, and then I wanted to label the boxes, how many ways could I do it? Or if you want to think about it a different way, I have n sets of things that map to a particular point under a function. Namely, each of my buckets here in my urns, each of my urns corresponds to one of the groups of things that's going to map to one of these n things. And then I just have to choose which of the n things is it going to map to. And so what that means at the end of the day is, either way you look at it, I can answer this question by starting with S of mn and multiplying this by the number of ways to either label the buckets from 1 to n, or if you want, assign the buckets to the n elements from 1 to n, which means that you're going to get this times n factorial. Okay. And so the answer for this final bit is actually this big S Stirling number, mn times n factorial. And that is our last slot here in our table. Okay. We're going to stop there for now. I'm going to put up a couple more videos where I'm going to do just a couple more counting problems where we think through all of these things. But I think this is a very clarifying way to think basically through almost everything we've done so far in this course as far as counting and putting it all into clean categories to let you think about it. Until next time.